Hello, this is Chris from the Motion Bench. In the previous video, we assembled the frame for the Zero-G Nebula Plus that I'm building. In today's video, I'll go through the process I used to square the frame and make it more rigid. I'll walk through the techniques I used to get the frame square and then show the methods I'm using to stiffen it up. This includes adding L&T brackets to the outside corners of the frame, along with X-cable bracing across the rear and both sides of the printer using turnbuckles and steel cables. This is actually my first time using X-cable bracing on a printer frame, so we'll treat this as a bit of an experiment. Later in the series, I'll revisit it and see how effective the bracing really is once the machine is fully assembled and running. Quick disclaimer, this video is not sponsored and no company had any input into its content. Let's get started. If you saw my previous video, you'll know that before tightening everything down, the first thing I did during assembly was make sure all the frame edges were aligned. Any place where the frame pieces intersect, I want to go through and use these 1, 2, 3 blocks like so to ensure that the faces are aligned with each other and perfectly smooth. That way there's no ridge or gap between any of these surfaces. And I did this all the way around the frame, every corner, every mating surface. Now I will say that using the kit like this from LDO makes the entire squaring process a lot easier. As you can see, these ends are machined very accurately. So when assembling the frame, you know, the square edge meets up against the square edge and you effectively get a square corner more or less. It's still important to check things as we go, which we're going to do next. If you're building a frame completely from scratch, the squaring process can be quite a bit more involved. The idea, if you're cutting your own extrusions, is you need to make sure that these cut ends along every extrusion are as square as possible. There are some YouTube videos on creating a jig to help square those up. But, you know, at the end of the day, it's better to try to get them machined professionally if you can. That being said, I built my previous Mercury 1 3D printer with all custom cut extrusions that I did myself using a miter saw and some files. Just know that if you're cutting extrusions yourself and doing this manually, you want to make sure that these ends are all cut as flush as possible. And then just also know that your squaring procedure is going to be a lot more involved than if you were to purchase a kit like this. For this build, I'm using a combination of 1, 2, 3 blocks and a machinist square. You don't want to rely on adjustable squares or the cheap plastic ones you'd get from a hardware store. I found a kit of these on Amazon for about $22. It came with 4 different sizes. To begin the squaring process, I'll take a combination of my machinist square and my 1, 2, 3 blocks, and I'll just go along each edge of the frame and corner of the frame like so. So I'll take my torque screwdriver here and tighten this bolt down to an initial torque of 20 inch-pounds like so. And then I'll come around and do the same thing on the other end. I'll use the 1, 2, 3 block to align the faces. I'll use the machinist square to square the corners. And then I'll come in with my torque screwdriver and tighten that down to an initial torque of 20 inch-pounds. I'm going to repeat the same process around the entire frame. Once all my corners look good from that regard, I'll go back around the frame and check everything again. It's essential that you take your time with this and check everything twice. The last thing you want to do is set your final torque, get everything built, and then find out that you should have checked twice and made sure that everything was square, because it can happen. Once I've done that with these tools, I'll come through with a tape measure and simply measure my diagonals across each side of the printer. So in the case of the rear side of the frame here, I'll measure across the bottom left diagonal to the top right diagonal, and I'm measuring it at 100.2 centimeters. Now I'll come through the top left diagonal to the bottom right diagonal. And once again, I'm measuring in at 100.2 centimeters. Measuring the diagonals is the most accurate way to tell that your frame is actually square. It can look like it's square using your tools here and along all the corners and stuff like that, but it could very well still be out of square. For a frame of this size, a difference of about 0.5 millimeter or less between the 2 diagonal measurements is generally acceptable. If the difference is larger than that, the fix is fairly straightforward. You want to loosen one corner of the longer diagonal and push the 2 corners of that side slightly toward each other, and then measure again before tightening the bolts back down. This part can be a little bit tough, especially because you have all your other bolts tightened down to an initial torque of about 20 inch-pounds. If the frame doesn't want to move easily by hand, clamps or even a ratchet strap around the frame can help pull the longer sides into alignment while you tighten things down. Or if you're planning to add cable bracing like I am, you can install the cables at this stage and use the turnbuckles to help pull the frame into square before setting the final torque on the frame bolts. I'm using these suede style toggle turnbuckles that are normally designed for cable railing systems with wooden posts. I'm choosing this specifically for aesthetic purposes. I adapted the mounting brackets by slightly bending them so that they can be mounted inside the corner of the frame at 90 degrees. I'm going to mount these inside here, and then I'll mount the opposing side here. In addition to the cable bracing, I'm going to be adding these L and T-shaped plates to every outside corner of the frame and along the rear of the Hydra upright. The reason I removed the bottom rear extrusion from this is so that I can mount this T-plate in place, tighten the bolts down, and then once that's done, I can re-add that extrusion back in place. So I'm going to go ahead and do that right now. These mount simply with some M5 bolts and the same style T-nuts that we're using for the rest of the build. So I'm going to go ahead and set this plate on here like so. Once again, I can use my 1, 2, 3 block to ensure that the mating surfaces are flush, and tighten one of these bolts down first, just to snug, and then I'll go through and tighten the rest of the bolts down. And once I have these bolts all snug and everything is flush here and aligned, I'll go through and I'll torque these down to a final torque spec of 20 inch-pounds. We don't want to over tighten these because these little T-nuts can strip out pretty easily. So we're only going to 20 inch-pounds on these plates. Now that this plate is installed, I can go ahead and reinstall the rear extrusion like so. All right, so that's installed. The next thing I'm going to work on is installing these cable braces. So to give you a general idea what this is about to look like here in a second, this one will mount down to this corner like so, and this one will mount to this corner like so, secured in place with some M5 bolts and T-nuts, and then there will be a cable that I'll crimp in these connectors along this style here. There are a lot of ways that you can implement cable bracing. A more traditional setup uses eye bolts and standard turnbuckles like these would work just as well. I chose the style that I did purely for aesthetic reasons. I just like the fact that it'll blend in and it'll look like it belongs as part of the frame, as opposed to having these much larger style turnbuckles like this. But these kind of turnbuckles with some M5 bolts on each corner will work just the same. All right, once installed, the turnbuckle and the receiving end will look like this. I'll go back through and I'll add another one to this diagonal of the frame, and in between each of these I'll add some of this 1/8 inch black steel cable, crimp it down inside of the both ends here, and proceed forward with this installation. And there you have it. This is what it'll look like once it's installed. Hopefully you can see the reason that I chose to go with this style of turnbuckle instead of the other one. This blends in almost seamlessly with the frame, and it just really looks like it belongs here. So that's why I went with that. Now, if you're having trouble getting your frame square, okay, let's go along and measure here. So for example, let's say that this diagonal, the measurement across this diagonal is exactly 100 centimeters. And then the measurement for this diagonal is 100.4 centimeters. What that will mean is that our frame is 2 millimeters out of square. So in order to adjust that and get the frame back into square, we can tighten the turnbuckle on the longer side down while constantly checking our measurements and making sure that we stop tightening this one once we achieve, in our case, the 100.2 centimeters. So I'm going to measure this again, and I am right at 100.2 centimeters. So I'm going to stop tightening this side. Now, the thing about these cable braces like this is you don't want to over tighten them. If you start cranking them down too much, it'll pull the frame completely out of square, and then you'll have a bigger problem on your hands. When you're using it to make minor adjustments, let's say 1 to 2 millimeters, they're perfectly fine. All you do is you tighten the longer side up until you get the measurement that you're expecting from one corner to the other. And then from there, you stop tightening this one. And then you go to this one, and you just want to match the tension along the opposite diagonal without pulling it back out of square. So when I tighten this one up and it makes this diagonal 100.2, then this diagonal also becomes 100.2. I know that this side of the frame is perfectly square. Then I'll go ahead and I'll tighten this one up as well. Like, it's not super tight, but it's not loose, and it's not pulling my frame out of square. Once I've adjusted these turnbuckles like so, I'm going to double check my measurements here again. I am at 100.2 centimeters. On this diagonal, I am also at 100.2 centimeters. So now I know that this side of the printer is completely square. All right, once I have my turnbuckles and cables tightened right where I want them, I'll go ahead and lock these in place. And just like so, this side of the frame is done. This is also the first time that I've used cable bracing like this on a 3D printer frame, so this part is somewhat experimental. In theory, the cables help resist racking forces that try to twist the frame into a parallelogram shape when in motion. I don't know if these cable braces will have any effect, if they'll work or not. But when, later on in the build process, once I get the machine up and running and able to print, I will test these out further. I'll start with them completely loose with no tension on the cables whatsoever. And then I'll go through different iterations of testing and see just how tight that I should make these cables in order to have any effect, if there's any effect on them whatsoever. Again, I've never used these before, so this is my first time doing something like this. We'll see what happens. All right, so now we know that our frame is square. Our two diagonals along the rear side measure at 100.2 and 100.2 centimeters. We have our cable braces installed. They're not overly tight, but they are tensioned. And this section is square. So it's time to move on to the final step, which will be to add L-shape brackets to each of the corners of the printer and along the side of the upright here, as well as a T-shaped here across the top side of the rear Hydra upright. Another thing that I want to point out is the purpose of these plates is to just help increase the stiffness of the frame. These plates should not be used to try to help square the frame at all. Your frame should be square before you install these plates. These are just support materials to keep everything from twisting and racking and stuff like that. While you can use these cables to make minor adjustments, I would not use them to make major adjustments. I'd probably, anything over 2 millimeters, I would go back through, loosen it up, and square it up by hand before continuing on. Otherwise, you risk damaging your frame, bending some bolts, or running into problems later when things start to slip outside of the spec that you kind of forced them into using these. But if you're just doing minor adjustments, like 1 to 2 millimeters max with these cables, that's fine. Otherwise, don't use these cables to try to square your frame any more than that, and don't use these plates here to try to square your frame. All right, so now that we have all of our L brackets installed, I'm going to go around and torque all these bolts down to 20 inch-pounds. From there, we know that the rear side of our frame is square. We've got our X cable braces installed. We've got our T brackets on the Hydra uprights installed. And that's a complete side of the printer frame. I'm going to continue on and finish the other sides. Remember, I'm only adding X cable bracing along the other two sides of the printer. I'm not adding it across the bottom at this stage, nor across the top. I will maybe look at testing that out in a future video. All right, so as you can see, we've got all of our corner L brackets and T brackets installed, and we have our X cable bracing installed along the rear and two sides of the printer. With that, the Zero-G Nebula frame is fully assembled, squared, and reinforced. In the next video, I'll start installing the Hydra 3-point bed leveling system and begin moving into the motion and mechanical components of the build. As always, if you're interested in building a printer like this yourself, or if you find this content helpful or informative in any way, please consider leaving a comment, liking the video, and subscribing to the channel. It really helps support the growth of a new channel like this. Thanks for watching, and see you next time.